Climate change, carbon dioxide emission, just how bad are the impacts? The truth is, business as usual in this energy-hungry world will be dumping more CO2 in the atmosphere going forward. Our planet is calling for immediate actions and asking us to think of sustainable ways to take some of that CO2 back now. Why now? There is a direct correlation between the amount of the CO2 in the atmosphere and the global increase in temperature. As of last month, we reached 415 ppm, part per million of CO2 in the atmosphere. And business as usual will be heading to 450 part per million, set by Intergovernmental Panel on Climate Change as the undesired threshold for 2 degrees C increase. I can guess what's in your mind right now. If we stop using fossil fuel, we can actually solve the problem of carbon capture. However, despite our advances in renewable energy, fossil fuel accounted for 85% of the world energy economy. What about the future? You guessed right. It is projected we will maintain dependence on fossil fuel for decades to come. It's a real challenge in front of us, screaming for real actions. How can we solve this problem going forward? The idea is to deploy an effective circular carbon economy, use efficiently carbon dioxide. However, you cannot store nor use what you cannot capture. The good news is there is existing technologies that can capture CO2 from power plants. However, it is very expensive to capture CO2 from plants. It costs around $90 a ton per CO2. Why is it expensive? It's because existing technologies and materials does not afford the capture of CO2 at very low price. So many research groups in the world are working heavily to develop better materials for capturing CO2 at an average price below $50 a ton. However, in KAUST, we took in a different challenge. We wanted to capture CO2 from the atmosphere. Access to these materials will allow us to actually mitigate the emission of CO2 from very specific transport areas like airplanes and maritime cargoes. Indeed, we developed a material that can capture CO2 from air at a price that's below $100 a ton, which is way below existing prices in the market. What are those materials and what's unique about them? Can you imagine yourself being a chemist that assembles things like a Lego? This offers great opportunities for a material designer. It will allow him, the designer, to make materials by choosing the building blocks for a made-to-order material with desired properties for a given application. Indeed, metal organic frameworks, MOFs, are specific materials that can be designed. You can imagine yourself in a lab at a molecular scale that you can be an architect. Choose molecular building blocks to be assembled into a material with desired properties for a given application like carbon dioxide capture, for example. In fact, those materials can have high surface areas almost as big as 1,000 square meters per gram or even 7,000 square meters per gram. Here is an example that shows a MOF designed in KAUST that allows you to store large amounts of natural gas on board vehicles. The methane in 5 cylinders is exactly the same amount on only 1 cylinder that actually have MOF on it. The building block approach to our materials does not only allow us to have high surface area materials, but allows us to control the entrance to these materials, and thus we can discriminate between entering molecules inside. Yeah, we can sense that with our approach, we can actually design materials for carbon capture from various streams, and why not from air? In fact, the concentration of the CO2 in the air is very low. Thus, we have to design a very special material that can selectively interact with CO2. Note that the amount of CO2 is 400 times below the amount in flue gas. So our materials are so unique in a way that we can actually control the entrance to these materials. As you can see here, we managed to design a material that has a periodic array of hooks or handles in these channels that can selectively interact with CO2 even at very low concentration, meaning that this material selectively captures CO2 from air, and you can take the material, leave it right here, and you can suck CO2 straight from air without any problem. As we speak, metal organic frameworks or MOFs made at KAUST can actually pave the way to a cost-effective and energy-efficient capture of CO2 from air, direct air capture. With collaboration with our partners, as we speak, we actually design a platform for demonstration for 1 ton of CO2 per day with less than 100 tons, which will be deployed to be 160 tons per day at less than 100 tons. With more energy efforts and more funding committed to direct air capture, I am sure that we will be enjoying the use of our fossil fuel energy and in a greener way and keep our planet greener and healthier for for our kids and grandkids. Thank you.